Actom, a global solutions energy partner, offers market-leading technologies and advanced products and services to the electromechanical industry. Thank you for joining us in this informative webinar where we will be unpacking the preventative measures for maintaining power transformers. I'd like to, before I introduce you, ladies and gentlemen, I just want to read you a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel, and by default, it's located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE TV channel. On YouTube, you will find the registration link in the chat box. Please click on it and register. It's free. This recording will be under the corporate partner, Actom's playlist on the SAIEE TV channel. The certificate of attendance will be issued a few days after this webinar. I'd like to introduce you to our panelists today, Wesley Foster, who aims to spread awareness about digital solutions that can simplify and enhance our lives. As an IIoT specialist at Actom Smart Technologies, he leverages his expertise to introduce innovative technologies and solutions that streamline industrial processes, improve efficiency, and make our world more accessible and easy to navigate. I'll hand you now over to Wesley.
There we go. Thank you very much for the introduction, Minx. Okay, so starting off, thank you very much for everyone's attendance. As the presentation says, we'll be going through the preventative maintenance of transformers. So as Smart Technologies, we've actually helped a couple of our sister companies with digital solutions. We've been trying to utilize as much as we can digital solutions to make life easier for all the employees and customers that we have, and to really guarantee that we bring value to them. One of the most exciting things that I've learned from recent presentations and things is that IoT isn't a new topic by any means, but it has brought up so many new and interesting applications where it's really starting to show the value of these installations and kind of justifying the cost of them now. So as Smart Technologies, we've done a couple of different installations already. We're mainly focusing on the electricity and power industry, seeing how we can better utilize data that we get from these devices. If you guys look on the slide now, you guys will see we do everything from big transmission transformers, we do mini subs, we're looking at distribution transformers, generator monitoring and fuel tracking, energy meters, also on the billing side of that, solar PV installations, and also the electrical motors, where we actually look at the expected life that the motor is going to put out through the actual vibration monitoring. Okay, so for today, we're only going to be focusing on the big transmission transformers. We have a case study that we did with one of our sister companies, Actom Power Transformers. Okay, so what are we talking about when we say predictive maintenance of transformers? We have to look at a couple of aspects in how we can actually extract that data to analyze it and then be able to predict. So we work according to this slide here. So we connect the devices that don't have internet connection. We collect the data. We then store that data in either on-prem or cloud server. And then we analyze that data and then bring it to visualization through a dashboard of some sorts. Okay, so why is it important to do this? The main advantages are can be monetary, but most of the time it's ease of use and also assists with servicing of equipment on a timely matter. As anyone will tell you in power, transformers are a lot easier to repair than replace, and it's a lot more cost effective. So first up, you'll see asset maintenance prioritization. That's a big one, just so that you can kind of work on the problem child of the group. Remote visibility, having a quick view from your cell phone or from your computer without having to go onto the SCADA really assists with giving everyone a view of what's going on. Event-based alerts, very, very important. Looking at when there is signs of trouble coming, it's best to have your technicians or your engineers be aware of that immediately. So event-based alerts are very important to set up, but also to make sure that you are actually adding benefit by having those alerts, not just having a lot of spam come through. Historical data, this is where the magic happens with the predictions. From historical data, you can kind of see a trend and then work with it to give you a desired outcome. Also very important to know what data is important to you, so you don't just clog up your database. Analysis and prediction, as I said, that's part of the historical data. And then service level agreements. So let's say you have a transformer that's on an SLA. You can actually have both parties, so the manufacturer of the transformer and the actual municipality look after, or client look after that transformer together. Two hands are better than one. So then when you're on the SLA, your manufacturer could actually tell you there's something wrong, you guys have to go check it out, or if they are responsible for that, they can then go out for that. It's also important with transformers to know that yes, you have your regular maintenance and it is on a SCADA, but the regular maintenance only calls for once a year where you have to actually do the gas testing in the oil. So it's always that what happens right after that? What if the transformer were to fail after a week and it could have been prevented? So having that hands-on or eyes-on approach is really beneficial. Okay, so how do we do this? We obviously need the rules to play the game. We are obviously not, or myself, I am not a transformer specialist, but obviously we have a division that is fully expert in that. And these are kind of the guidelines that we use to make sure our data is accurate and that we can actually predict when something is going to go askew. The most important one, I would say, is the guide for the interpretation of gases, which gives us our min and max values, especially on the combustible gases. Okay, so as I said, just a little bit more about that IEEE standard. With the different gas levels inside the transformer, we can then see when a potential problem is going to arise. Depending on which gas is more prominent or which ratio is higher than the other, we can then intelligently say that that is the problem. The dissolved gas concentration, so depending on which condition it falls under, that would give us the actual severity of the problem. Okay, then getting to the pilot. So the pilot we did was with Bokumosa, and that was through APT. They had a serious issue with this transformer acting up from time to time, and then we had to put the condition monitoring on there to kind of see what is actually going on. Because no one is actively looking at the data, it was a great, how can I say, a great opportunity to actually showcase what we're able to do. Okay, so the architecture of the solution. When we look at it, it's basically the connect part. I'm going to use my mouse here. So we connected the power analyzer, the cooler controller, and the gas analyzer all to a gateway or edge computer, whatever you want to call it, and then connected that to our private cloud. So this is the part that actually does most of the work. We use the gateway to push up the data into the cloud, where we then work with the data. We can then analyze it and visualize it through a web client of sorts. Just to elaborate on the solution here, so we take the Modbus data, it could be serial data as well, doesn't matter, and then we convert that to MQTT to get it to our database to actually utilize it. Another important thing to know is with the IoT solutions, you have to really understand that the devices could be different, and the way the gateway actually gathers the data from the equipment might be different. So from brand to brand, there could be a mismatch. But the biggest thing is to try and get to a point where we can utilize all the different types of vendors into one system, basically giving us a sensor as a service type of agreement, lowering the cost. So that's where we want to eventually get to. Next, I have a quick demo of the dashboard. You guys will see here on the dashboard, it utilizes a quick overview. So just giving you the most important data from each device, then a individual dashboard for each device, and then an events panel. I'm going to play the video. The video is 2 minutes long. I'm going to try and explain as we go along. So overview, you guys can see here, we have all the different values on the power side of things. We also have we can see that there are some voltage spikes with fuses with phase 3. Going over to the historical data, we can go back to as far as a year and then check if there's a trend that's more prominent. We then go to the dissolved gas analyzer. Here we have our combustible gases at the top, because obviously those are the most important. Those are usually the ones you want to look at. And then our non-combustible gases here at the bottom. You'll see that we can then, these are live figures, so set to an interval that works for you. We can then choose to only look at certain gases, where you can see there's a slight trend forming here with the actual carbon monoxide, which could be useful, which would of course raise an alarm if it went over a critical state. Sorry guys, the video starts over from time to time. So obviously the events are there, or the event alerts are there to actually notify when something is wrong. We don't expect anyone to monitor these dashboards, especially if you have a large fleet of them. It is very difficult to have eyes on all the time. So that's where the data analytics really assist. Okay, going to the power meter, power analyzer, we can see here that everything looks pretty normal. It cut once or twice, but we can see on phase 3 it is spiking a little bit. On the cooler controller, we have the loss of life calculation. So this is a standard brought it up in one of my previous slides, just an IEC standard that we can track to give an accurate prediction on the actual life expectancy of the transformer. So here we're at the events panel. So every time there's an alert brought up, it'll throw up the event and then take a snippet of that event to be analyzed at a later stage. Here you can see that we actually have the model of what happened there or what caused the alert, and then we can analyze from there what actually went wrong. You can have a look at the voltages and the currents, look at the phases. That's it. Okay, then obviously, more importantly, you want to be able to report on this automatically. The way of doing manual labor is quickly running out, so we don't need to do our reports manually anymore. All of it can be sent on a monthly basis or bi-weekly basis as and when required. And it gives you all the information about the actual transformer. You'll see here that some of the points have been highlighted automatically, where it gives the red as a bad value and then the green as a good value. So with this, it makes it a very valuable solution, and we've been installing these as a add-on to the transformers to assist with all the monitoring and keeping up with SLAs. It has been hugely beneficial to both parties to understand transformers better, and we hope to actually drive this to a point where we can more accurately get an understanding of how to improve the transformers in the long run. With this, it has been a little bit of a fast presentation, but I'd like to thank everyone for joining. If you want to actually have a live demo or have any questions after the show or after the webinar, please do not hesitate to contact me. Thank you, Minx.
Thank you very much, Wesley. We have one question here. Ladies and gentlemen, please type your questions in the questions panel and I'll ask Wesley your question. Wesley, if you could just switch on your webcam. We have a question here from Mason Kista asking, what is an SLA?
So SLA is a service level agreement. So generally when you are procuring a transformer, you could get the manufacturer of the transformer to actually look after it for you. That can be by agreement, so it depends to, it would be dependent on the discussions that were held, how far that SLA gets taken, but we can put you in contact with someone if you need more information.
Excellent, thank you. Another question we have from Vernon Akir asking, do you have data of real-life transformer faults from customers to guide the loss of life, or do you completely depend on the IEEE standards?
We completely depend on it, on that for now. We would need quite a bit more data to actually have the a more real-life calculation or real-life, how can I say it, prediction. So for now, we only have the two IEC standards. We're following the latest one.
Thank you. Another question from Vernon, for Mr. Akir. How do you integrate the sensors into the transformer? Can the manufacturers be influenced to integrate?
Yes, so this is quite an advanced transformer, but all the equipment can be installed by the manufacturer. It is on a request basis as far as I understand, but gas analyzers are technically the most important and I think more widely used. They could be, in this transformer we had a 9-gas analyzer which was able to give us a lot more information, but you could have a slightly smaller one, like I know AAA does like a 2-gas, which you could do basically the same thing with, just on a smaller scale.
Thank you, Vin. We have another question here from Tabang. Daniel Chele is saying, hello, I wanted to ask as to what mainly causes the power dips in transformers.
So this is a nice question to ask the transformer guys. Sorry guys, I'm going to say that's beyond my expertise. There could be a multitude of issues that cause that.
Excellent. I'll just give Mr. Tabang Actom's details, Actom Power Transformers details to get it answered there by the professionals. Not saying you're not one. Another question.
I'm telling you guys I'm not.
Good. Another question from Andrew Akbamuchi. Is the software used an OEM customized software or Actom bespoke software?
So this solution is a bespoke solution. We had to develop it from the ground up because there is no shoe that fits one size fits all type of scenario, but we are trying to get to a point where it is a product that we can just roll out.
Excellent.
It depends very much on the communication. Sorry, Mings.
No problem. Okay, thank you. Another question from Reten Muhammad asking, what kind of gateway do you use?
So we use a in-house built gateway. There are a multitude of gateways that you can use with different configurations and interfaces. Yeah, we do tend to look at ones that have dual SIM just to have that failover. If one signal is worse than the other one, then we can use like MTN or Vodacom.
A fail safe.
Yeah, but there are a lot of different brands that you can use.
Okay, excellent. And another question from Blessing Siabonga. He's asking, does the client get to monitor the transformer themselves or does Actom do that?
So it could be both, actually. That is up to the customer at the end of the day. If there's no SLA, then it might not be in our best interest to do that, but it could be both. We could set it up so that you have a couple of users at the customer site or the actual manufacturer.
Thank you. From Retent Muhammad, a question, what kind of gateway do you use to push your information to the cloud?
So it's just a basic, like I said in the previous answer, it's a basic board that we built and put into a IP certified enclosure. We then connect it to a cellular modem and then that pushes up the data.
Okay, thanks. Lehlononolo Mulapo is asking, how does your system differ from the online dissolved gas device, which isolates the transformer automatically upon realizing that a gas has risen to a catastrophic level?
Yes, so the gas analyzer will still have ultimately the control. That and the Buchholz relay will basically keep the transformer from going totally haywire. But this is more to prevent it getting to that point. So the values that we select are a lot more conservative than the ones that might be used to actually cut the power on the transformer. Yeah, it is very important to also understand that that would just be a dashboard and no analytics would be behind that. You won't have the historical data and all of that at the back end.
Okay. Another question from Blessing Siabonga asking, does Actom install the sensors on the client's transformers? It doesn't matter who the manufacturer is, i.e. the OEM.
You'd have to talk to Actom Power Transformers about that. I'm not sure if they would touch another manufacturer's transformer. Okay. But we could look at a bespoke solution as well. So maybe just send me an email about that and we can discuss it further, okay?
I will definitely do that. From Bekani Ngube is asking, can you place the sensors in the casing of the transformer? Which would also
so the sensors are certified to work on the transformer, Basically, what happens is they attach the sensor to the transformer in manufacturing to not cause any. Because the thing is, as many of you know, is with the oil, the best solution is for that is to keep it closed. You don't want to open it. So it is a thing that's more done in the manufacturing of the transformer. So yeah, I hope I answered your question there.
No problem. Thank you. Mr. Charles Gaunt is asking, the gas analysis slides were passed over very quickly. Is the analysis only by gas ratios?
So the DGA, yeah, we mainly focus on the gases because that is generally what causes the issues, and this is what this customer really wanted to see. So if there's other values that you'd like to extract out of that and visualize or analyze, then we can set that up for you guys.
I suppose the question that Mr. Vernon Akir is asking now, do you have other products that you can also monitor? You just answered.
Yes, so we have a couple of vendors that we've already worked with. Are you specifically talking about the transformer solutions or any of the other solutions? Sorry, Vernon.
That's good. We'll just get Mr. Akir to respond to that question. Let's just move on to the next one because we can come back to him.
Okay.
Tamizi Mavungu, my apologies for the pronunciation of your name, is asking, can the software trip the transformer when gases are outside the limit or still wait for transformer protection?
It would still be based on the transformer protection. So this would only be a monitoring software. It has no control in it. We even keep it separate because we do not want to touch the critical communications. So that would all still lie with the DGA or the whatever cuts the transformer's power there.
Okay. Norman Mapimele is asking, can the software initiate alarms and trips? This can help save the expensive equipment.
Yes, that's exactly it. So what we've done is we've allocated this as a mobile app to some of our customers who actually maintain a specific transformer. This one was pretty easy because there was only one transformer, and then the person that needs that information gets that information. The alerts are also set up in a way where it actually is important to receive, not just like your Facebook that just spams you with notifications.
Excellent. We don't want that. We've got a question here from Marty Visser that says, I would like to know if the analysis also deal with harmonics. Harmonics are also troublesome. Do you have any studies on harmonics and the effects?
No, but we could explore that option as well. I'd like to actually hear what you guys require there, or how we could integrate that. If you guys have some.
Yes.
Okay, great stuff.
We have a question here from Odarile Kuruta. Please elaborate further. What role does data analytics or condition monitoring play in optimizing preventative maintenance strategies for power transformers?
So how we saw it is that we can kind of pick out the bad apples. We can see which ones are not running to spec, especially with like APT or Actom power transformers. They have a good understanding of their transformers and how that transformer or that size of transformer operates. So by gathering more and more information about them, we can then more accurately predict when a failure is imminent or when a small issue could turn into a big issue.
Thank you. Next question from Luanda Zakwe is asking, which specific gas concentration / combination indicates a more critical or urgent issues with the transformer?
To us, or to me, I wouldn't know. I'd have to say that APT would have to give you a clearer answer on that. To me, all of them are important, so we highlight all of them. I think the most important one that's been in discussions is carbon monoxide, or that ratio specifically. The rest of them, I'm not too sure about.
No, thank you there. Andrew Agbamuche is asking, does this process work for dry type transformers?
We do not have a solution for dry type transformers yet, but could be interesting to explore.
Excellent. Akshay Ashko-Kumar is asking, can this monitoring system be implemented on existing transformers, or can it only be implemented on new transformers?
So if we can extract the data from the actual protection equipment on the transformer, if it has digital equipment on there and has an output that we can read, like RS485 or Modbus or whatever the protocol might be, we can definitely retrofit this to a existing transformer.
Okay, so Mr. Akir has answered. Remember earlier he's asking, do you have other products that you can also monitor? And he says, with reference to other products such as cables, MB boards, etc.
Yes, so we actually busy with the installation now that actually requires us to monitor RMU units. Only on the condition monitoring side for now. Also with MV switchgear, we are trying to kind of get more understanding around that. We obviously have our MV switchgear division, which is helping with that. And then later on, we're actually looking at doing the distribution automation, which is one of our more ambitious projects, but we hope to get there.
Excellent, thank you. Just give me a second here. I've got one of your colleagues, Ms. Sai Gura, to also online, who can also perhaps ask help with the questions. Seeing that you are the software fundi there.
Maybe just assist Wesley a little bit with the technical questions. So one of the questions I see you smiling now. So one of the questions that was asked is, can we actually propose the solution for any other transformer besides Actom transformers? Definitely. So in terms of the solution that we developed for APT, so we part of Actom Smart Technologies. So we are looking at all the other divisions to assist them in terms of either their process or their equipment. So one of the questions that was asked was, can we monitor any other stuff? So we literally build solutions around whatever the problem is. So we analyze what the problem is, whether it's an equipment, whether it's cable, etc., to try and get a solution around it. So with regard to other transformers, we definitely are able to monitor other transformers, as well as on the existing transformers, we put in devices. For example, if required, a DGA pressure monitor as well as a temperature monitor. So we monitor all of those so that we are able to data analyze correctly in terms of what's wrong with the transformer. But what we're doing currently with our new transformers, specifically with Actom, is that we have actually designed where these monitoring devices need to go in. So it makes it easier for us to retrofit if required at a later stage. So that's one of the advancements that we've done. And I think in terms of a question that was asked with regard to can the customer monitor? So currently we've got 2-year and 3-year SLAs with the customer where we do provide this information. So by analyzing the gases, especially acetylene, we are able to determine that there is a major problem in the transformer, and ahead of it actually blowing up, we are able to then give this information to the customer. And they're also able to analyze the life that is left in the customer. So, in the transformer, which also will assist them in terms of planning to replace the transformer, for example. And I think one of the questions that was asked is harmonics. So obviously in terms of harmonics, this does affect the design of the transformer as well as the warranties of the transformer. So one of the reasons why we actually monitoring the transformers, especially on the IPP side, is to ensure that the transformer is actually operating within the design parameters. And we can also give extended warranties if we're able to actually monitor these transformers. So I think in terms of IoT devices, we do have other IoT devices as well that we are able to install depending on the need of the customer. So depending on what the problem is, we literally develop in-house solutions for it. So I hope that helps with some of the questions.
Thank you so much, Sai. You really, and I could just inform the attendees that the questions will be sent to Wesley, and then he can also direct it to the right division, as Actom has several divisions that can also assist with any questions we couldn't get to. A question here from EBS and Sai. Thank you very much. Please stay online. You can maybe also assist if a question gets posed to Wesley, and he can just pass it on to you. EBS Kufas is asking, you seem to say sensors are installed at manufacturing. However, I understand the Bokomoso project was brownfield. Does it mean the sensors had to be retrofitted then?
Sai?
Okay, so yes, we had to retrofit those sensors. We had a DGA on site, but we had to retrofit the pressure sensor as well as the temperature sensor. But with the new IPPs, we're actually giving a proposal or an option where you could fit it before the transformer leaves the factory. But sorry about the background noise. But the other option is that we have it already designed so that we don't have to kind of make a plan on site in terms of how we attach the devices, so that it is an option at a later stage as well that you could fit on the IoT devices. And if, for example, it's PTK specifically, which is a much smaller transformer, then we don't go to the 9 gas, because obviously the 9 gas DGAs are quite expensive. And hence, I think Wesley mentioned that we are looking at options of 2 gases as well that will do the same function for the PTKs.
Thank you, Sai. We've got a question here from Mr. John Wilson. He's asking, do you have any similar software for smaller power transformers in the range 3 to 15 MVA as used for wind turbines?
So I think I've partially covered that question with, so we have designed a solution for that. It's already in the market to a couple of the IPPs. Is that correct? Yes.
Wesley, you want to add something?
Yeah, that I was just thinking now with the wind turbine transformers, but someone answered it correctly.
Great, thank you. So from George Aubert, he's saying, what is the business case? Cost of installation versus life cycle, cost of transformer. Which minimum size is recommended?
Wesley, you want me to come in?
Yeah, you can go for it.
Okay, so obviously on the bigger transformers, I think it's perfect because you're paying a couple of million for that. Most of them already have a DGA device that you've already paid for as part of the manufacturing of the transformers. So in terms of getting the data, it's a very minimal upfront cost or either a monthly SLA cost. So you can work out the sums. It's actually no rocket science. However, on the smaller transformers, it wouldn't be advisable to put a full DGA on it. It would be most probably a 2 gas DGA that we actually put on it. So we were recommending basically maybe from 40 MVA upwards, because most of those transformers would have a DGA already as part of the installation. But we can give a solution on any size transformer basically.
Thank you. Shannon Brink is asking, is the system user-friendly? For example, would the customer be able to set their own alarm set points?
I think that would be on request. So this would be like a discussion we'd have with them before actually going live with the system. So adding users isn't a difficult part, but adjusting the set points for the alarming, I think we would have to do. But we could also probably train that person to do it themselves. But you'd have to have some background in that.
Maybe just to add on to Wesley's comment is that the current alarms are set in terms of the IEC standards. So they're very specific in terms of how we've set them. So obviously there would need to be a really good reason why we change it. So it is adaptable, but it would be good to understand why you would want to actually change those settings.
And also, just to add on to what SAIEE said, there is remember that we want to give the most valuable information. We do not want to clutter it up. As soon as you start dropping the values too low, it can flood you with alerts or useless information, which won't be helpful in the long run.
Excellent. Question from John Wilson again. Do you have any recommendations for surge protection or enhanced winding protection?
A
little bit outside our scope, I think. SAIEE, do you know?
Yeah, it should obviously depend on the size of the transformer, etc. But we could, if you have a specific requirement, we could actually put you in touch with the guys that sell the surge arresters as well as the transformer designers.
Excellent. And then maybe, SAIEE, you can answer this question from Rutent Mufamad, asking, maybe in the near future, do you have any devices that helps with harmonics? I think you did touch on that.
Yeah, so in terms of harmonics, it's more a design parameter, and obviously you've got your CT lab instruments in terms of power quality that measures that. So I think power quality devices normally measure harmonics, but currently we don't have a requirement in terms of trying to measure that. But if it is a requirement for a specific client, we are working with the Vector 3 and the new launched meters at this stage. So it's something that we can easily look at as well.
Thank you. Mr. Norman Mapimele is asking, is this only for gases or can it check moisture and kV per millimeter? I think it's millimeter.
Moisture is also part of the monitored gases. Let me just quickly want to check on the other one. Moisture is part of it. The other one, I'll have to get back to you, sir.
Okay, well, I'll send you all the questions anyway, which you can then answer. Okay, Mr. Wilson is asking again, do you have anything to cope with increased damage to power transformers used in Munichs? The range 15 to 30 MVA due to much greater number of annual switching and cold load in rush due to load shedding.
Sorry, can you just repeat the question again?
Do you have anything to cope with increased damage to power transformers used in Munichs? The range 15 to 30 MVA due to much greater number of annual switching and cold load inrush due to load shedding.
Okay, so with regard to that, obviously with the switching, the biggest criteria is the inrush currents. So that is normally in terms of the protection that is set on a transformer as part of the substation. And each one of those transformer protections has got relays and stuff, which is one of our divisions that does look at it. So I think the first thing that you need to do is look at all your protection relay settings to ensure that it does cope for that kind of inrush current, or there is a trigger where it actually protects the transformer before it is switched on at such a high inrush current. So that's something that can be looked at in terms of the protection philosophy as well as the relay settings.
Thank you. We have a question here from Florida's Moloto. What is your current lead time on a 20 MVA and up?
So in terms of monitoring, is that the question most probably? So we've already got all the devices set up. So for us, it would be a quick thing. As soon as you require it, once you place the order, we would be able to ensure that you get the monitoring as soon as possible.
Excellent. And our last question from Evias Kufa. He's asking, what is the return on investment provided by this solution? How can I justify the solution to non-technical financially inclined stakeholders?
So obviously the rate of return would be proportional to the cost of the transformer. And I think everyone knows from PTKs all the way up to 150 MVA transformers, the price ranges from a couple of million to a lot of millions. However, I think the justification would be, in a case like this, you would know before the transformer either catches on fire or actually has a failure. So you would be able to determine before it actually happens and have a remedy in place. So imagine having, for example, a transformer being out. It takes weeks. In fact, to manufacture a new transformer, you're looking at between 8 to 12 months to get a new transformer if you don't have a backup plan. So if you have a whole town off at your major infeeds in terms of the transformers coming into a town or a Munich, I mean, it's major implications with loss of supply to these major customers. So definitely in terms of trying to explain it to non-technical people, it'd be, can you imagine the cost of having 290 MVA transformers switched off or 245s switched off and you don't have a backup? Whereas with this, you would be able to say where the problem is. And actually one of the things I'm sure Wesley showed you was that it determines the life left of the transformer as well, depending on how hard you're pushing it. So if you're doing a lot of switching, especially with the load shedding now, you've got an issue where you are reducing the life. And the moment you're also operating the transformer outside the design parameters, you're also reducing the life. So those are the kind of things that you can see, and it helps you to plan in terms of the capital budget going forward as well. So I think for a non-technical person, that could be the easiest way. But if there's specific transformer sizes and stuff, we could work it out for you as well, depending on the current pricing of replacing those transformers.
Thank you very much, ladies and gentlemen. Thank you very much for your all your questions. The questions that we haven't been able to answer, I will forward the questions to Wesley and the team to answer to you, and your email addresses will be attached to the questions so they can just answer you directly. Before we go, I'd just like to bring your attention to, in the chat box, there's links to the SAIEE TV channel. Please register so you can receive notification of the recording of this webinar if you missed something or you joined late. Also, you will find how to become an SAIEE member and information on how to become a member of the SAIEE. You'll find the online link of the What Now magazine, which is also loaded as a handout in the section, which in a PDF format, which you can quickly download. But I'd like to just use this opportunity to thank you, Wesley. We really had hair-raising moments with the dry runs, trying to get the system to work. It was really great meeting you, e-meeting you. Thank you for the wonderful, informative presentation. Sai, thank you for backing up Wesley, for coming in last moment, unplanned, but I'm very happy that you were online to help us with some of the technical, physical transformer questions. It's always great dealing with Actom. Ladies and gentlemen, with this, I say thank you for joining us today, and please look out. We're planning a whole lot of Actom webinar series for next year. But if we're not seeing you again online, please have a fabulous and very safe festive season. I cannot believe I'm saying this in the end of November. But everyone have a wonderful day further and stay safe. Goodbye.